We're starting our University of Bridgeport Math 105M mini lectures, notes, and workbook series. Now, what we have here is I've taken our textbook, gone to the teacher resource, and then pull these out. These are mini lectures on the various topics we'll be covering in Math 105M. Now, there are other topics in our textbook, and I have lessons on YouTube from our old Math 100, which covers all of the topics of Chapter 1, most of them of Chapter 2, of 3, 4, and then we start bringing in some of the Math 105M topics. But if you need background, I strongly advise you to look at some of our other stuff that we have posted on this site. So I've given this message. You should prepare for these lessons by reading and studying your online textbook. Now, remember, the textbook is your major source of information. It covers all the aspects of things in a particular topic. It gives you reading, it shows you pictures, it gives you examples, works them out. The only thing it doesn't have, as the textbook, is somebody talking to you and showing you. But in MathLab, there are videos as well. When you do your practice, there are videos you can check on to see a little something and hear about it. So there's plenty of reference out there to help you master these skills needed to complete Math 105M. And I'll let you read that on your own here. Oh, but I should stress here, do I have in there a homework log? Yes, homework log. This is just a spiral booklet of some type in which, as you do your practice and as you do your quiz-mes, you write them out neatly and orderly. One of the main things we're looking for in math is to develop this orderly, neat series of events that lead you to a solution. And again, as I say here, also a good record of review items, and then if you have a question, whether you bring it to Math Zone, the people in Math Lab on Fridays, or to the Learning Center on the 5th floor of the library to help you, you get your job done. And again, it's okay to work ahead, but try not to fall behind. Then you don't finish the course. Okay, so let's get started. We're going to take a look at exponential notation and scientific notation in this topic. And this is how these mini lectures are set up. They have learning objectives, which kind of go over the main topics that will be discussed, and then they give you examples to work them. And the nice thing about this is down at the bottom of each of these pages, they give you the examples, or I should say the answers to these examples. What I'm going to do here as part of our review is to work them for you and give you some background. Now, some of you may know a lot about this, not so much, but I'll try to give you the material needed to develop mastery in these topics. So starting with example 1, it says multiply or divide, then simplify. And we have blank pages on your left This is where if you need more room, you can write things out. This is going to be pretty much a requirement that to be active in this class, you need to take notes, you need to be involved. This is this part of the course. And your notes then serve as a reference throughout the course. If you don't complete the course in one semester, generally you would get an incomplete and then work on your own using your notes and Math Lab to complete it and then take your exit exam. So what do we have here? Well, we have m to the fifth times m to the sixth. So what are we doing here? We are multiplying variables. And the rule for multiplying variables is a to the n times a to the m. And we just add them and get a to the n plus m. That's the rule. So all we're going to do here is add the exponents and get m to the 11th. Now, as we look at letter B, it's something similar, but notice on this letter there is no exponent. Well, when there isn't an exponent, a 1 is assumed to be there. So we multiply our numbers. 4 times 2 is 8. A to the fourth, a to the second, add them. A to the sixth, b to the third, b to the first, b to the fourth. So again, just a couple of examples that you will then use this rule in your practice and then later your quiz me to develop mastery points for this objective. Now here we're dividing, and the rule is if you have a to the n divided by a to the m, what you do is you take this exponent up to the top, and the sign of the exponent as it crosses this division bar changes and becomes the opposite sign. Here it's positive, up there it's negative. And it makes sense. If we added when we multiplied, we're going to subtract when we divide. So 2 goes up, becomes negative, and we get r to the fourth minus 2 now. As it comes up, becomes r to the second. And here we do division of numbers. 2 goes into 10 5 times. There's a 1 there that we're going to subtract from the 2. So we get x to the first. We don't write it. I'll just put it there. And then y to the first comes up. We subtract it from 4. Y to the third. Okay, so that was pretty straightforward there. Now we'll clear that. You could always go back and rewind, so to speak, and watch something again, but you want to be able to do it. Now here we're saying that x is 4.6. So generally in a parentheses we put 4.6, and we're saying it's to the 0 power for this first one. And the rule for anything to the 0 power is always going to be 1. So x to the 0 or this to the 0 is 1. Now here we're going to put a negative sign in front of the x. Now notice there's the x, and x is just this. So our negative sign has to be outside of the parentheses. So what this is, and sort of you could have it like this here is what they have. It's going to be 1, but now we apply the negative, so that would be a negative 1 in both of these cases, because when we replace x with anything, whatever that is 1, and then we apply the negative sign. So this is going to be a negative 1. Remember, we said this was a 1. Now for this one, again, we're putting a negative, and then we apply the 4.6 to the 0 power. The negative now is included as part of the base. So this is a 1. Anything to the 0 power is 1. Here the x is to the 0 power. The negative is not included. And we went over that. Okay. Now I'll raise this up a little bit too. Now as we look at this next part in here, we're dealing with negative exponents. Now, where do the negative sign of exponents come in? Let me give you a little lesson here. Suppose we have a to the second, and in there is actually a 1 that we don't write in front, and there's a 1 there that we don't write in the denominator. But if I wanted to move this a to the second down to my denominator, that same rule we spoke of just a few moments ago, the 1 that's up there stays, the a to the second comes down, but when it crosses this division bar, this fraction bar, the sign of the exponent changes. So this is what a to the second is. It's equal to 1 over a to the negative 2. Ah. So what do you think 5 is? Well, again, there's a 1 there, and there's a 1 underneath. We don't write these ones, but we are sure to put the 1 in our numerator to designate there's the numerator. We're now going to bring 5 to the negative 2 down. As it crosses this division bar, it becomes 5 to the second, which when we simplify becomes 1/25. All right, how about this one now? Notice the negative sign is included there. So this is going to be 1 over a negative 5 to the second. Now notice the negative sign is part of that base, and that comes down as well. They're not asking us for a negative sign out there by itself. That would have resulted in it being a negative, by the way. But here we get a negative 5 times a negative 5. Again, it's just a 1 over 25. And we want positive exponents here. An error might be if we take the 3 down. That would be incorrect. The base of our negative 6 is only the x. So the 3 stays on top. The y to the 4th stays on top. And just x to the negative 6 comes down as a positive 6. And in letter D, what do we have here? Well, as we showed in the beginning, when we have a negative exponent in the denominator, it just moves up and becomes 6 to the second power. Its exponent changes its sign from a -2 to a +2 as it crosses this division bar. And this can be simplified to 36. Now I put the 1 there showing that it came from the denominator. We don't usually write the 1. Now in this case, we are raising a power, a to the m, to the nth power. In this case, raising a power to a power, we don't add, we multiply. And you might say, well, why is that? Well, let me show you. Because it's 3 to the second times 3 to the second times 3 to the second times 3 to the second. So this 4 indicates that this base is written 4 times. So this is going to end up being 3 to the 2 times 4, which is 8. Or in this case, we would just add all the 2's and get 3 to the 8th. So here, the result is a to the m times n, a multiplication. Now, again, they want it in positive exponents, and the rules apply that if this is positive and this is negative, we're going to start with y to the -18. But again, there's a 1 there, and there's a 1 underneath. So we leave the 1 up there in the numerator, bring our negative exponent down, and it becomes y to the +18. And here, again, the rules apply. A negative times a negative will give you x to the 12th. Negative times negative makes it a positive. Now you're going to get other problems, other examples than the exact ones we're showing here, but that's your challenge. And keep in mind, if you need more information, it's in our textbook. You can read it there or watch the review that I did in my other YouTube videos. Okay, they now want us to simplify these and always looking for positive exponents. Let's raise this up a little bit more. And then we can actually see the answers down here too. Okay. So again, the rule, if you have a negative as part of your base and you're raising it to an even power, your answer is going to be positive. If it were to a if it were to an odd power, that would be negative. But we'll have to see if we get one like that. Okay, so this is going to end up positive. And remember, this is 3 squared, which will a -3 squared. -3 times -3, +9. And there's a 1 right there. We're multiplying. We get a 2. Now, since this is a negative here, we're going to have to be careful with this because this is going to be a -5, and let me write it like so, a -5 that we're going to raise to the -2 power. That's multiplying this item by this. Then we're going to go x to the 4th times a -2. which will give us x to the negative 8. And now y, negative 3 times negative 2, y to the 6th. So that's sort of an intermediate stage. We're now going to have to move these down to the denominator. And let me move it over here. So this becomes y to the 6th is what stays on top there. This goes down to our denominator now as a negative 5 to the 2nd and x to the 8th. Well, what is negative 5 times negative 5? Well, it's a positive 25 x to the 8th. And that was 4b. Let's see where 4b is here somewhere. 4a, 4b. I'll have to check that out. No, we're looking for 5b, and that's what we have. Y to the 6th, 25 x to the 8th. Very good. Okay, I'm going to erase this because we'll need the room. Now we're going to raise a fraction to a power here. So we multiply this and we multiply, remember it's down there too. So this becomes x to the 12th over 3 to the 3rd power. So that's a 27. Now here, a couple of things can go on, and I could show you this technique. Now you could do it this way, watching the signs. But another technique, when you have a negative exponent and you have a fraction, to make this a positive exponent, you take the reciprocal of your fraction. So this is going to be 4 over z to the 2nd y to the negative 3, and then all of that will be, now that I've used the reciprocal, to the 3rd power. So 4 to the 3rd power, some of you might know that, that's going to be 64. Z to the 2nd times 3 would be z to the 6th. Now this is going to be y in the denominator here to a negative 9, but we want it to be positive. So we can now skip a step and just move it up to the top as a positive 9. And here we are right here with it. Perfect. Okay, we're going to go to scientific notation in just a moment. Now, the basic rule of scientific notation, as we see it here, is that it's a number between 1 and 10 times some power of 10, 10 raised to some exponent. Now, to convert then, as we see in standard form, a large number, we have to move our decimal place and watch how it works. So I'm moving it 1, 2, 3, 4, 5, 6, and then one more, 7, to make this a number 45, or 4.5 I should say. I moved it over 7 places, so now it's a number between 1 and 10, and then this will be raised to the 7th power. That is scientific notation. If you're already familiar with it, again, you don't need to spend a lot of time, but you may have to go look at your textbook. Now for small numbers, again, it's the same procedure. It's a number between 1 and 10 times some power of 10. Now, when it's a large number, your exponents are going to be positive. When it's a tiny number, your exponents are going to be negative, as you'll see. But again, keep track of the zeros. How many places you move it? 1, 2, 3, 4, 5, 6, 7, 8. You moved it 8 places and you got 7.58 times 10, 8 places, negative 8. So negative 8 indicates this is a small number. Now here you have it in scientific notation, and the number is 5. And we need to have, let me erase that for a moment here. I got to move it over. We got the 5 here. So there's our decimal. Now, how many places do we need to move this decimal? It's right here. Well, we need to move it 5 places to make it a small number. So we have 5. Moving it 1, that's 1 place. So we have to add 4 zeros so that we can move it 5 places. 1, 2, 3, 4, 5. And then we usually add another 0 to fix the decimal place. And there's our answer. Now for this big number, let's write it up here. It's 1.234, and it's to 7 decimal places. Well, if we have 3 decimal places, how many zeros do we need to add to make it a total of 7 places that we move? Well, this would be 3. So we add 4 more zeros. 1, 2, 3, 4. So that when we move it, 1, 2, 3, 4, 5, 6, 7, we're moving it a total of 7 places. And there's our answer right there. Okay, when we do multiplication, as they're showing here, we're using a little bit of a technique we had before. We have to multiply these two numbers. So I'm going to get my calculator, and I go 1.4 times 2.3, and I get 3.22. Now here there's 1 decimal place, there's 1 decimal place. So I ended up with 2 decimal places in my answer, and then I go times 10, and I just add my exponents here. 5 plus 4 is 9. Now in a sense, that's in scientific notation, and then in some classes that's how they want you to do it. But here, if you put that in MATLAB, I believe they'll count it incorrect because they want significant digits. So how many significant digits do you have here? And the answer is 2. How many here? 2. So in your answer, you have to have the fewest number of significant digits. So here we have 3, so we have 1 too many. So what we do is we look at this third place here, and since it's less than 5, we just drop it. So that's where they get this answer from. Okay? Now, when we do letter B, we're going to divide 4.2 divided by 3.71 and get, we get a big number here, 1.1320, and it keeps going on. Well, we're not going to have all those places, so we'll just see what we have here. Now we have 10 to the 5th, When that goes up, it becomes 10 to the, again, it changes its sign. Up here it's a -5, so this becomes a -11. But how many significant digits do we have here? 2. How many here? 3. So again, in our answer, we're only supposed to have 2 significant digits. So we go to what we have, and since this is less than 5, we just drop all of that, and then that is our answer. Well, this is completing our first of many. I hope to do all of them, and we'll be using some of these in class. But keep in mind, this is where they're going to be. You go to YouTube, type this in, and you can see these and all of the others. I spent a lot of time doing this background for you, and hopefully it will be useful.